All right, function 2. Let's start by looking at example 4. Now, example 4 says this is given that f of x is equal to x squared, where x is any real number. We're to show that f of x is a function. B, we're to determine the codomain of f of x. And C, we're to find the range of f of x. All right, let's start off with A. Show that f of x is equal to x squared is a function. All right, let us represent the relation f of x is equal to x squared as an arrow diagram. So x in the domain would be mapped onto x squared in the codomain. So we have what? Minus 2, minus 1, 0, 1, 2. Let's choose some domain values. We could have what? If you square x minus 2, you get 4, 1, 0. Fine. So here, this corresponds to here. This corresponds to here. 0 corresponds to this. 1 corresponds to 1. And 2 corresponds to 4. Let's just put on some other values down here. So these other values are simply what values of the codomain. So we have the domain values and we have the codomain. All right. Now, how do we determine if this relation is or is not a function? The rule says if one arrow leaves every element in the domain, the relation is a function. If more than one arrow leaves any element in the domain, or if no arrow leaves an element in the domain, then the relation is not a function. So from this, we can clearly see that the relation f of x is equal to x squared is a function because only one arrow leaves every element in the domain, indicating that every element in the domain is mapped onto only one element in the codomain, making the relation a function. Another way you could look at it is that you could do a sketch of the graph of the relation. All right, this is my y-axis. This is the x-axis. This is the origin. All right, fine. So, oh yeah, to determine if a graph is, to determine if a graph is a representation of a function, or a relation expressed as a graph is or isn't a function, we will do the vertical line test. Essentially, the vertical line test says that if every vertical line I could draw cuts the graph only once, the relation is a function. So that is, if every single line that I could draw parallel to the y-axis cut this graph only once, the relation is a function. And then now, if I can draw at least one line that can cut the graph, one vertical line that can cut the graph more than once, then the relation is not a function. All right, so let us have a look. Let's draw one vertical line. All right, I'm drawing one vertical line, and I notice that this vertical line cuts the graph only in at one point. So, and I can imagine that every single vertical line I could draw would cut this graph only once. Therefore, I could say for A, f of x is equal to x squared is a function. B, all right, we're asked to determine the codomain of f of x. The codomain are all possible values of y, and as you can see, y could be what positive and y could be what negative. So we could say that y is an element of the set of real numbers is the codomain of f of x. And lastly, we're asked to find the range of f of x. Now, The range are the values of what? Y, or the values of f of x in the codomain, which are actually mapped onto elements in the domain. The range are the actual values of what? Y in the codomain, or actual elements of the codomain, which are images of the what? Of elements in the domain. So from the arrow diagram, we could see that the positive numbers are what? Are elements of the range, whereas what? Negative values of y are not elements of the range. From the graph, we can see that the graph does not fall below what? Below the line y is equal to 0. Therefore, there is no coordinate, there is no ordered pair that corresponds to a negative value of what? Y. Therefore, all the values of y for this function must be positive. So C, um, y is greater than or equal to 0 is the range of f of x. Remember, the range are what? Values of y which correspond which corresponds to values of x in the domain. All right, and the only values of y that correspond to values of x in the domain are positive y values, and positive numbers are greater than 0. So y is greater than or equal to 0 is the range of f of x. Example 5. In example 5, we're asked to identify the codomain and the range of y is equal to 4x minus 5. So we're asked to identify the domain and the range. All right, y is equal to 4x minus 5 is a linear relation, and the graph of a linear relation is a straight line. So we could do a sketch. Y, x. All right, x. We could do a sketch. I'm actually didn't even think that we needed to do a sketch. Minus 5. All right. From just examining the equation, you can clearly see for every value of what? For every value of x, and x could be any real number. X could be a positive number, x could be a negative number, x basically could be what? Any real number. So if x could be any real number, I would say A, the domain is the set of all x such that x is an element of the set of real numbers. All right, because for every value of what? X, there is a value of what? Y. So it means therefore that what? B, y is an element of the set of real number is the range of y is equal to 4x minus 5. And essentially what this is saying, for every value, for every real number, for this linear relation, every real number in the range will correspond to a value in the what? Codomain. For every value of x, there must be a value for what? Y. Therefore, for every value of y, there must be a value for what? X. So element, x is an element of the set of real numbers, would be my what? Domain elements. And y is an element of the set of real numbers, would be my range elements. All right, find the domain and range of um, y is equal to x squared minus 3x plus 2. All right, I guess this could be best illustrated by a sketch of of a sketch of the relation y is equal to x squared minus 3x plus 2. Let's do a sketch of it. In order to do a sketch, it would really be good if I could arrange it. I could complete the square and arrange x squared minus 3x plus 2 in the form a into x plus h square plus k. All right. In this arrangement, um, minus h k would be the turning point. All right. Here, using a formula, h would be equal to what? B over 2a, and k would be equal to 4ac minus b squared over 4a. All right. A we can see is equal to 1, B is equal to minus 3, and C is equal to 2. So that's coming from the quadratic expression. So H would be equal to minus 3 over 2 times 1, which is going to be minus 3 over 2. And K would be equal to 4 times 1 times 2 minus minus 3 square all over 4 times 1. So h is equal to minus 3 over 2, and k would be equal to, this would be here 8 minus 9 over 4. So it will be minus 1 over 4. Therefore, um, 3 over 2 comma minus a quarter is my minimum turning point. All right, so let's try and do a sketch of this relation. If I do a sketch, I have my y-axis. All right, there's the x-axis. All right, from the relation, the y-intercept is 2. And 3 over 2, a quarter, is the turning point. Ugh. All right, I'm not having a good sketching day. All right, let's focus. All right, so this is my turning point, which is the point 3 over 2 minus a quarter. This is my line of symmetry, which is the line x is equal to 3 over 2. All right. This is the y-intercept, which is 2. All right. The minimum value of y down here is y is equal to minus a quarter. So there's no value of y below y is equal to minus a quarter. All right. And as I said, we're asked to determine the domain and the range. All right, for I would say for all polynomials, um, the x is an element of the set of real numbers is the domain. So for this polynomial, a x is an element of the set of real numbers is the domain. Now now the range. The range would be what values of y which correspond to a value of what x. All right, so that is from the graph, and from the graph you can see that the graph does not fall below y is equal to minus a quarter. Therefore, y is greater than or equal to minus a quarter is the range of the relation. Example 7. All right, we're to identify the domain and range of y is equal to ln x minus 2. All right, you cannot have ln e of a negative number. You can't have ln e of a negative number. So therefore, x minus 2 must be greater than 0, greater than or equal to 0. Sorry, must be greater than 0. Therefore, x must be greater than 2. All right. We should remember the graph of y is equal to ln x looks like. Um, so graph that looks like this. This is my y-axis, the x-axis. Now for this graph, x is equal to 0 was the asymptote. All right. But now x is equal to 2 is the asymptote. So 1, 2, 3. So that is my new asymptote. All right. And the graph would look something like this. And the value here would be 3. 2 here, 1 here, 0, x-axis. All right, so the domain elements, a domain is x is greater than 2. All right, because no value, every value that is less than 2 will not correspond to a value of y. Every value less than x is less than x is equal to 2 will not give you a value of what y. All right, or any value of x which is less than 2 is going to be asking you to find ln of a negative number, which is impossible. All right, b we're asked for the range, and as you can see, the range would be any value of what y. The graph is going to continue down in this direction towards infinity, and it's going to continue up in that direction going innocent. So every value of what y is a possible value, or every value of y will correspond to a value of x which is greater than 2. So y is an element of the set of real numbers is the range. All right, example 8. Now, example 8 is the last question, and in example 8 we identify the domain and range of y is equal to e to the minus x plus 2. All right, let's do a sketch of it. Now, in the graph of y is equal to e to the minus x, the x-axis, which is y is equal to 0, is an asymptote. And when now, but for y is equal to e to the minus x plus 2, I mean that is going to what push the graph 2 units up. So therefore, the new asymptote is going to be y is equal to 2. So this is the x-axis, which is the line y is equal to 0. All right. Um, let us see. This is the line y is equal to 2. All right. Y-axis. I think the graph comes something like this. All right. So you can clearly see that the values of y do not fall below y is equal to 2. But the values of x could be any value in that direction and any value in what that direction. So the domain x a, the domain is x is an element of a set of real numbers, and b, the range, is y is greater than 2. The range is y is greater than 2. All right, so that's the end of this session.